Hi, and welcome to a video on error analysis. In this video, we're going to continue talking about distributions. And specifically, we're going to talk about continuous distributions. In previous videos, we said that if you can increase the number of observations and limit your bin size, you'll notice that your discrete distribution starts to take on the appearance of a continuous distribution. In other words, it becomes less blocky and more smooth. Some distributions will look like this. This is known as a Bell or normal or Gaussian distribution. And you get this kind of distribution of measurements if your measurements have random and independent errors. Here is the equation that governs this curve. Along the bottom axis is x, and along the vertical axis is your g of x. This curve is nice, and the equation that we have helps us understand the probability that a measurement will fall within a certain range. The range that we're looking at is a standard deviation. We calculated standard deviations in other videos, and one standard deviation, this curve shows, and the calculation shows that the percentage or the probability of observations lying within one standard deviation is 68%. So in other words, 68% of all observations that you made to produce this curve will fall within plus or minus one standard deviation either side of the mean or the average. This curve shows the probability that measurements will lie within certain standard deviations. On this curve, you can see the first standard deviation accounts for 68% of the observations. And as you increase the number of standard deviations away from the mean, it increases the number of observations or measurements that are found within that area. So one standard deviation equals approximately 68% of all of the observations. And if we go out to 2 standard deviations, that'll give us 95.4%. And here's a graphical representation of that. Going out 2 standard deviations, notice how you have more of the curve within those bounds, so more measurements. And a measurement that you make, there's a 95% chance that it'll fall within that area. The confidence interval is how sure that we are of an observation falling within that stated uncertainty. In this case, we're looking at CDs. This is an example going back to our measurements of the diameter of a CD. We said the average diameter was 12.8, and we came up with a standard deviation of 2.9 millimeters. If we apply that to this curve, then that means 68% of all of our measurements will fall within one standard deviation, which is 2.9 millimeters either side of the mean. And 95.4% of all the observations or measurements will fall within 2 standard deviations, which is 5.8 millimeters either side of the mean of 112.8 millimeters for the diameter. So that's how we can use continuous distributions to determine the probability based on standard deviations.